talked to Dan before. Hi, Dan. It's nice to see your face. You're on mute.
Hi, Christina. Nice to see your face too. You've been a big
Nice
help.
Yeah. No, I'm actually really excited. Your student's doing great, man. She's trucking along.
Yeah.
Excited to see the progress she's making. So fingers crossed this Friday for her.
Right. Yep. Definitely.
But yeah, man, I'm really super excited. And the last time I talked to her, I think she was almost in tears because she'd passed. She's got 2 out of 4 of the sections of the test down. So
right,
get the last 2 done.
Yeah.
Jacqueline and Kathy, I'm not sure if I've talked to you. I apologize. There's hundreds of you and only one of me. So sometimes I don't know who I talk to. Have I worked with either of you two before with either of your students?
No.
Okay. Well, it's really nice meeting you.
All right. I think we should get started.
Sounds like a plan.
Okay. Oh, well, hello, everyone. My name is Miguel Diaz. I am the program coordinator for the Jefferson Mon Valley area. This is my coworker. Many of you guys might know her. Christina Indovina, she's the tutoring specialist. Today, we're going to talk a little bit about, and I'm going to share my screen just so you guys can see. We're going to talk about the base, the 4 basic operations. Is this sharing at the moment, Christina?
It's sharing if you want to put it into presentation mode.
Okay, is that better?
No, we're still, yeah, no. Now I'm looking at us again.
Give me a sec. I think this is better, correct?
Yes, that's perfect.
Okay, so we're going to be looking at the the basic four operations. Okay, we can go to the next slide. So what are the goals for tonight's presentation? It's really just to get a fuller understanding of the 4 basic operations. And it's also so you guys can have, as tutors, right, have more tools in your toolbox when you are working with your student. This is probably a student with emerging math skills. So we're thinking about somebody beginner to who is maybe using MathSense 1 as well. Okay. And the website that we're going to be looking at is Light and Salt. It's a series of videos. There's what's the tutor's name? Christina, do you remember?
Oh, the woman's name, she's a GED educator. I think she's out of the state of California, but I'm not positive. But her name is Kate Redman. So that's, I mean, it's basically the whole website was her brainchild.
Mm-hmm. So Kate just sort of goes through different videos explaining different problems that students encounter in the GED or the high school equivalency tests, and she focuses on some of these topics. So the one we're going to be looking at today is going to be the 4 operations, but she has other videos, right, on exponents, squares and roots, integers, absolute value, value, distance. If you guys, some of your students might be struggling with some of these topics, we recommend to look over some of these videos, and we are going to link the website to later on. We're going to provide you guys with the link to her website. All right, and I think this is another series that of modules that Christina outlined as strongly recommended for you guys to look over at some point, right, with your students.
Miguel, I can take it from here.
Okay.
But what I'm thinking, I'm just realizing that I'm gonna have a hard time. All right, here we go. I'm gonna request the remote control of your screen here. Awesome. Okay, so we definitely recommend this presentation, the video that we're going to be watching. I actually think it's worth watching this video with your student at some point. I just think this woman does a great job. You could recommend that your student watch it on their own and then kind of cover it later. And the reason why we really I'm not even going to say that this was, I'm not even sure how to describe it. The first time I watched this, I'm not a math person. And the first time I watched this video, it really changed the way that I was thinking about math in a way that I think it was just like all of a sudden I was able to see the operations from different dimensions. And I think had somebody explained these operations to me this way when I was like in grade school or high school, I think math may have been less of a mystery. So it's one of the reasons why I think this is just, it's a useful 30 minutes of your time to go through. Students who are getting through the foundations level may benefit from this if they're using the foundations level book as a refresher. If you have a student who is like brand new to math, and we do have some students, especially English language learners, who just never covered beyond like addition and subtraction. If they're just learning like the theories of multiplication and division for the first time, this website's probably going to be too much. But if you have anyone who went to school in the States, dropped out in high school, very likely the things that this woman is covering are going to be at least ring true a little bit for them. So this is the website. It's called Light and Salt. Miguel, am I going to be able to? I just realized this is the awkwardness of trying to do this digitally. Can you bring up the website for me?
Okay.
Thank you. And go ahead and share the website. All right, so if you've never seen this website, she has kind of a whole series of videos that she's going through. Hold on one second. I need to get back to the remote control. There we go. All right, so she has kind of a whole series of videos that she's made. She's got the crucial GED basics, which is the one that Miguel was talking about. These are kind of all the things that if you are working with a student who's kind of new to the concept of like high school equivalency and they're working through kind of the basics, the crucial GED basics is worth reviewing. And one of the things that I really like about these is that she doesn't just give you like basic information. She has a video and then she has kind of worksheets that go with it. She also goes into algebra, slope and line, GED, data analysis. And then we did briefly talk about this word problems one. The way that I came to know this woman actually was from the word problem section of this, because I feel like this is the best explanation of word problems for the GED that I have found anywhere. And I know if anybody's looked at the GED or the GED Ready, the GED test itself is something like 65 or 70% word problems. So your students have to be able to do them in order to kind of get through. So I would strongly recommend, just even as a tutor going through, if your students are struggling with this is a great, great resource. And without further ado, I can play the video from here. So before we get started, I do want to just take a second and just ask folks, like, does anyone have any questions or comments at this point? Because we're gonna get the video started. We're gonna watch about 30 minutes of it at the end and try to just have a conversation. Miguel and I have put together a worksheet kind of covering the topics that this woman is covering in this, because she's going to cover a lot. We've put together a PDF. We want you to use it, like we want you to pay attention. So we weren't going to send the PDF, but we have the PDF. We can put it into the chat and then we can email it to you afterwards. But I just don't want you guys to feel like you like have to take all the notes right now, or like if you miss anything. Miguel, what's going on?
I think I was just optimizing
here and it's like crashing. Okay. So does anybody have any questions, or are we good to start? Yes. All right. I'm going to say
Sure.
it sounds like we're good to go here. All right. Bring this back to the beginning. Here, Miguel, I'm going to let you drive. All right. Why don't you get the video started?
Students, we
Is everything
Hello,
showing?
virtual GED students. We are back after our month hiatus, and I am so excited for today's lesson. I feel like a really big slacker because I haven't taught this so far, because this is probably the most crucial lesson in all of mathematics that I teach. And I don't know why I put off doing it so long with my virtual GED students, because it's usually the very first lesson that I teach to any new student coming into a GED class. We're going to talk about the basic operations. Now, a lot of students get mad at me during this lesson. Kate, why are we talking about the basic operations? I've been doing that since elementary school. I don't need your help with that. And I say, if you understood some really crucial things you're supposed to understand about the basic operations, you wouldn't be making the mistakes in algebra that I see you making. Okay, math is math is math. I don't care if you're working with whole numbers like we did in second grade, you're working with fractions like we started doing in third and fourth grade, decimals, negatives, algebraic expressions, whatever kinds of numbers you're working with, the basic operations are going to guide how we work. So what am I talking about? What is Kate talking about? First of all, the word operation. We've got David with us here today. David, do you know what I mean when I say operation in a math class?
No.
Okay, well, there you go. That's the place to start, huh? Operations are the things we do with numbers. So, you know, on the very first day of math class, probably way back in first grade, your teacher said to you something like, if Jimmy has 3 candies and Tommy has 5 candies, how many candies do they have total? And you did some math to find that answer. What operation am I talking about there?
Adding.
Exactly. So addition is a great example of an operation, okay? Then once you learn to add, your teacher had you say, well, you know, if we could put candies together, there must be a way to take them back apart. So we learned the opposite of addition, which is?
Subtraction.
Exactly right. Then one day your teacher had to recognize that sometimes there's a faster way to go. You know, she said, well, what if everybody in the class had the same number of candies? What if they each had 5 candies and we've got 30 students and we wanted to put them all together? So what would we be doing in that case?
Multiplication.
Exactly. And of course, once you learn to multiply, you could learn to do multiplications opposite. You could learn to take a total and break it into equal sized groups. I'd be talking about
Division.
exactly. So those are the 4 basic operations. Those are not the only operations on the GED, but those are the ones that come up most often. And these are the ones that really stump students who struggle with word problems as well as in algebra. And since the 2 biggest skills on the GED are word problems and algebra, we've got to cover this topic, okay? So go ahead, do me a favor, take your notebook, break it into 4 sections and title them for me: addition, subtraction, multiplication, and division. Now my tablet's pretty small. I'm going to try to squeeze in everything I need here, but I hope you have a nice big piece of paper to write on, because we're going to be talking about a few different things with these numbers. Okay, I want to talk about symbols. What do those look like mathematically? I want to talk about language, the official terminology we use, and I want to talk about what it means. And so that's going to help us relate what we're doing here to algebra, interpreting word problems. Okay, so let's start with symbols because that's the easiest way to go. Most people know what symbol we use to signify addition in math class. I bet you won't be surprised to know that it's that plus symbol. Looks like a little cross. I've never had a student yet who didn't know that that was the mathematical symbol for the addition operation, but I'm about to teach you a new word, okay? So the only reason I'm teaching you this probably won't show up on the GED is because math teachers use it, I use it, I want you to know what I'm talking about. That is the operand for addition. It is the symbol that tells you to add. It's the operand. You can see operand is like the same root as operation. The operand is the symbol that tells you the operation. Does that make sense?
Yeah.
Okay, cool. So we know the operand for addition. Do you know the operand for subtraction?
The negative sign.
Yeah, the little minus sign. Interesting that you called it the negative sign, because sometimes it's a negative and sometimes it's a minus. With addition and subtraction, it's super straightforward. We only have those symbols. We only use those symbols. I've been doing math for a really long time, and I can't think of another way that a mathematician might write addition or subtraction. However, that is not true of multiplication and division. They are more complex. So unfortunately, you know, we teach you this little time sign. We have you use it up until about 6th grade, and then it gets totally and completely dropped I will be very surprised if you see the times sign even once on your GED. In fact, if you do see it, it'll be in the first 5 problems where you don't have the calculator. But after that, once again, in word problems and in algebra, you will not see it at all. What will you see instead?
Probably a little dot.
Yeah, a little dot is one of the ways that we talk about multiplication. Now, be really careful. If I wanted to tell you to multiply, no, I'll put 3 times 5 here. If I wanted to tell you to multiply 3 times 5, that dot can't be down there on the ground. If it's down there on the ground, I think that you're talking about 3.5.
Mhm.
If I want 3 times 5, that little dot would be floating in the middle. Very frequently, they will use a dot or even a star. And those two symbols are brought to us by computer programming and the fact that we live in a digital age. They're very typical of computers, but they're still not the ones we use most common in algebra. In algebra, we don't even use the dot or the star as much as another way of saying multiplication. Have you ever seen another way to multiply, David? I bet you have.
Parentheses.
Parentheses. Now, I need to qualify that because every student I've ever met has told me parentheses mean multiply, and I say, well, not exactly. Let me show you what I mean. You don't have to write this down. I'm about to erase it. Okay, here are different mathematical expressions. Now, you guys might call those a math problem. I call them an expression. And it's important that you can use math language to understand the GED. So here are 4 different mathematical expressions. All 3 of them have parentheses, but in only one of them are the parentheses telling me to multiply. Do you know which one the parentheses are telling me to multiply in, David?
2, 3 plus 5.
Yes, this is the only one where the parentheses are telling me to multiply. Now, those are very complex expressions that I wrote. I don't need you to panic. I don't know what to do. I'm not asking you to do anything. All I'm asking you to do is that recognize that this is multiplication when the others aren't. Now, how can I tell? What you're going to notice here is that the only thing between 2 numbers in this case are parentheses. So it's not just the parentheses, it's parentheses with what I call proximity. Parentheses with proximity. When the only thing between 2 numbers is parentheses, that's when you know you're multiplying. Now, if you look in this case, you know, not necessarily the case. I got this minus sign between. I would think of that as a different way. And of course, in this problem here, I have something entirely else going on. I have a power, which we're going to look at in the next video. So let me go ahead and erase this and show you what how a mathematician would write parentheses with proximity. Okay? So if I wanted to say 3 times 5, I could write that a couple different ways. I could write 3 and only the 5 is in parentheses. But again, you're going to notice that those 2 things are in proximity. They're super duper close. They're almost touching. The only thing between the 3 and the 5 is the parentheses. Therefore, it's multiplication. And it could be that both the numbers are in parentheses as well. But what I want to point out to you that it's not really the parentheses that are telling us to multiply. It's the proximity. The only reason that I use parentheses is because of this. Imagine if I wrote 3 and 5 really, really close like that. Does that mean 3 times 5?
No, it's 35.
No, that says 35. So the parentheses are just there so you see that one's a 3 and one's a 5. It's the proximity telling us to multiply. Does that make sense, David?
Yeah.
Okay, cool. So then that it should make sense then that when a mathematician talks about a number and a variable multiplying an unknown number, they will just shove the 2 really, really close together. Like, for example, if I wanted to say 3 times y, bingo, 3y is 3 times y. Proximity alone is enough to tell me to multiply. So David, nobody has to put this into their notes, but David's pretty advanced here. I just want to let you know if you saw something like this on the GED test, right there, those 2 things are shoved together, 3 and the square root of 25. I don't have any parentheses there, but I got proximity. That's 3 times the square root of 25. Another example here, I have -3 shoved up against the absolute value of -8. I do not need to know how to do this problem to see that those 2 things are in close proximity. There is multiplication happening between those 2 things. Okay, so we now make sure we get that word in our notes, proximity. closeness means multiplication. Similarly, division, we gave you a symbol way back in elementary school. And can you read that expression to me that I just wrote there? David, when I say an expression, I mean both the numbers and the operands. I want you to read the whole thing.
15 divided by 3.
Very nice. I'm super glad that you said divided by. Now, way back in elementary school, when we didn't know how to divide by, your teacher would have you do some scratch work. You know, and when we do our scratch work, we would use a different symbol. That guy doesn't even have a name, by the way. He's not an official symbol. Math, math students think that that little division house or whatever you want to call it is like some math symbol. No, it's a way of organizing your scratch work for long division, okay? But what I want to point out to is when we wrote it this way, we did not read this problem the same way. This does not say 3 divided by 15. Do you know what this says?
15 divided by 3.
It is 15 divided by 3. It is equivalent to 15 divided by 3. However, if I were reading the 3 first, I would actually say divided into. So dividing into is different than dividing by. Okay, dividing into is how we would do our scratch work for long division. But this symbol up here is a divided by symbol. Okay, so the first one that you learned, and this is the one that mathematicians, we use dividing by when we write mathematical expressions. We will not use the divided into symbol at all. Okay, so the only place this sucker belongs is in your scratch work. I don't even want to see that in your beautiful algebra. Okie dokie. But we will use divided by signs. But unfortunately, just like with multiplication, I pretty much almost totally get rid of this symbol in algebra. I use a different symbol for divided by. Do you know what I use when I want to tell you to do 15 divided by 3?
You write 15 over 3.
That's right. I use a fraction bar. Now, students hate that because you guys have an irrational fear of fractions. No joke. I can make grown men cry by just saying the F word in class. But guys, let me point out 1,000,000 times over that all a fraction bar means is divide. It literally means 15 divided by 3. And I could do that division. 15 divided by 3, you know, that's 5. It's not a fraction anymore, okay? Fractions only get funky when I can't do the division. For example, 1 divided by 3 would not be pretty, so I would leave it as the fraction 1/3. That says 15 divided by 3, and this is the most common way we're going to see it in our algebra. Now, I do recognize that a lot of students have that lazy diagonal fraction bar. You guys like to write your fractions that way. I'm going to beg you not to. Not because you're wrong. Good news is you're totally right. I beg you not to because having worked with adults with disabilities as long as I have, I know that I could bring down your test score about 5 to 10% by just turning all the fraction bars like that. When your fraction bars are diagonal, your brain will have a lot harder time telling which number's on the top, which is on the bottom. You'll make a lot more errors. So save yourself the trouble, write them that way, and you'll make less errors in your math. Nice horizontal fraction bar. So we talked about the symbols. So let's move on then to 4 important words you need to know. They're very frequently used on the GED, and I will not be the least bit surprised when if you see one of these on your test at the end of the month, okay? The first word is the word sum. Now, I ask students what a sum is all the time, and students tell me sum is plus. And I kind of agree with you, but not exactly. Sum means a little more than just plus, okay? This is plus. It's just one little symbol, plus. A sum is talking about a whole math phrase. It's talking about a mathematical expression. It's an addition expression. So an expression isn't just the symbol, it's the numbers as well. So for example, there is the sum of 5 and 3. Or it could also refer to that expression's simplified, what GED students often refer to as the answer. You'll not hear me call it an answer. You'll hear me call it simplified, but I will make a nod to the fact that students will often call it the answer. So it's a simplified answer. So the sum of 5 and 3 is 8. So I could use the word sum to refer to that, what you think of as the problem, 5 plus 3, or what you think of as the answer, 8. But it would not just refer to a plus sign. Do you know the word for a subtraction expression? An addition expression is known as a sum. A subtraction expression is known as difference. Okay, guys, sorry, I had a little technical difficulty. We lost our screen, but we're back. Okay, so we are talking about the difference. So what does the word difference mean? When mathematicians use the word difference, we mean a subtraction expression, Can I squeeze in the word expression? I think I can. So for example, 8 minus 5 is a subtraction expression. Or, and here's something super important to the GED. In fact, I can't emphasize this enough. It's positive simplified answer. What the heck is Kate talking about? Positive. Well, David, do you have your GED calculator on you today?
No, I do not.
Okay. Do you have any calculator like on your phone?
Yeah.
Do me a favor. I want you to do 8 minus 5, 3. But then what if I did it the other way around? What if I did 5 minus 8?
It'd be -3.
Exactly. But when you talk about difference, what's the difference between, it doesn't make any sense for difference to be negative. Like the difference is just the size. Like, let me just draw you a picture over here. You don't need to put this in your notes. But for example, you know, if this was 5 tall and this was 8 tall, the difference is like this little piece that one has and the other one doesn't have. And
Yeah.
it doesn't really matter if you're talking about the difference between 5 and 8 or the difference between 8 and 5. That's still a 3-unit difference. Does that make sense?
Yes.
That's super duper important to the GED, and the thing you're most likely to forget about today's lecture. So highlight it, circle it. Difference is always positive. In fact, a lot of math teachers and also the GED answers will show difference like this. It's easy enough when I have numbers to make sure my answer is positive. I'll just put the bigger number first. So like if I wanted to know the difference between 3 and 11, I'd just go 11 minus 3. But if I don't know what the numbers are, like they're A and B, I don't know what they are, I would need a mathematical symbol that says whatever answer you get, make it be positive. That mathematical symbol is known as absolute value bars. So take a look at the expression I just wrote. It says the absolute value of A minus B. What does that say? Well, what it says is that first subtract your two numbers. Take A and minus B. But because I'm admitting I don't know if A is bigger or B is bigger, when you're done subtracting your two numbers, make your answer positive. That's all those bars mean. Those bars right there, absolute value bars as we call them, mean make whatever answer you get positive. And just here's a helpful hint to everybody watching. The first 5 problems of the GED frequently feature a distance or absolute value application problem. So you will probably see those bars. I need you not to freak out when you do. It means whatever answer you get, make it be positive. A subtraction expression or its positive simplified answer. And we see 2 subtraction expressions up there. So the difference between 5 and 8, I never finished my statement, is 3. Mad at me, are you good with sum and difference? Does that make sense, David?
Yes.
Okay, so then if there is a word for an addition expression and a subtraction expression, guess what? We've got words for multiplication expressions and division expressions, but these ones usually students are not as familiar with. GED knows that, expect them to come up. The one for multiplication is a product. A product is a multiplication expression. So here is the product of 3 and 8. Or I could do the product of X and Y. Now I just said the product of X and Y, meaning X and Y are multiplying, but I didn't write any symbol for multiply. David, do you remember why I just shoved X and Y together?
It's because of how close they are.
Yeah, exactly. When they're close, they are multiplying. So that says the product of X and Y. Or it could be the simplified expression, what you guys think of as the answer. Again, I can't stress enough that to a mathematician, that's not the answer. That's just the simplified expression. We just made the same exact expression a little simpler. But for example, the product of 3 and 8 is 24. So I could refer to 24 as the product as well. Okay, cool. And so I told David, but I'll tell the rest of the internet now that I very frequently see this in algebra. I wouldn't be the least bit surprised if the GED test asked you find the sum of X plus 1 and X plus 3, or find the product of X plus 1 and X plus 3. And if you don't know those words, you won't know what they're telling you to do. Okay, super important. We have products, and the last word, do you happen to know the word for a division expression?
Yeah, quotient.
Yeah, it looks, as soon as I started writing the Q, it usually jogs people's memory. So a quotient is a division expression. or its simplified answer. Okay, so for example, there is the quotient of 24 and 3. There is the quotient of x and y. And then, of course, I could say 8 quotient of 24 and 3. The answer could also be referred to, or what you think of as the answer, as the quotient. So you need to know these 4 words for translating algebraic expressions, which is always tested on the GED. It just
Okay.
will be. Now that we got that down, I want to talk about it from the other point of view, from the interpreting word problems point of view, the other big skill on the GED besides algebra, looking at word problems. So in order to know when to add, when to subtract, when to multiply, and when to divide, you have to understand what those operations mean, which is not the same as how to do them. I've never met a student yet that I had to teach how to add, but I've met plenty of students who had no idea what they were doing or why. And so they'd have a problem that perhaps had some more complex numbers, and they'd have no idea that they should add. Okay, so let's talk about not how to add, but what is addition. So David, I'm going to ask you a weird question that students never know how to answer. What are you doing when you add? What is addition?
You're making one number greater than another by adding more numbers to it.
You know, that's just the answer I was fishing for, because that is a false assumption that students make. You guys assume that adding means making greater because you guys are used to whole numbers. However, just an FYI, I could show you an addition expression where the numbers did not get larger. If I took -5 and I added -4, my number would get smaller, and yet I've still added. So
Okay.
clearly we've got an incomplete understanding of what addition is. Just keep thinking about this for me while I keep erasing. What do you think it means then to add? If it's not to make something larger, what is it? Yeah, we do it all day long, but what does it mean to add? Okay, so what it means to add is to combine groups. Quite literally, it's to combine groups to find a total. So let's put that down. So we're talking about addition by definition. When we're adding, we're combining any size group. You know, for example, we're just putting things together. We're just putting, and the groups could be any size. You know, I could have a group of 5 and a group of 11. Put them together, boom, I've added. I can have a group of 34 and a group of 82. Put them together, boom, I've added. And David's like, well, yeah, but every time you add, Kate, it got bigger. Well, what if I had, you know, could I put together my money I have with my debt? Yes, I could. I could have $55 and I could owe $62. I could still combine that. That would be an active addition. And yet I would see my bank account drop because I just put that debt on in.
Yeah.
Does that make sense?
Yeah.
Okay, so we're combining any sized groups there. We're putting groups together and we don't care about the size. Okay, wonderful. Then now we need to think, it's super important, you know, your elementary school taught you the operations that she did in the certain order that she did for a reason, even if you didn't understand her reasoning. Okay, so the first thing we taught you to do, you know, we put together Johnny's and Jimmy's candies, 5 candies and 4 candies. We added them together. But then the next thing she taught you to do was to reach back in to the total and pull out Jimmy's piece to undo addition. Super important you give me an arrow right here. The opposite of addition is subtraction. The mathematical word for opposite operations is inverse. If you don't understand inverses, you can't do algebra. Algebra is just the ability to work forwards or backwards. Okay, so we need to understand that the opposite or backwards of addition is subtraction. So then what does it mean to subtract? What am I doing when I subtract? I am removing a group from a total. Wonderful. Now let's go over to the idea of multiplication then. You know, there's actually lots of ways to think about multiplication. And the problem is you guys only have this really elementary understanding of it, kind of like with addition, and it leads you to make some super false assumptions when we get to fractions and when we get to decimals. Okay, so, you know, a lot of times I ask students what it means to multiply, and they tell me, much like you did with addition, it means to get bigger. And yet I know how to multiply things that actually get smaller. So you don't need to put this in your notes, but really quickly, if we have a calculator, let's try these. Some numbers, yes, when I multiply, they get bigger. For example, if I were to do 10 times 3, I'd get
30. Yeah.
But just because I'm multiplying doesn't mean things will get bigger. For example, 10 times 0.5. Type that into your calculator. 10 is not going to get bigger. 10 times 0.5 would give me only 5. There's other numbers I could multiply and it would not get bigger. If you were to type that into your calculator, 10 times 1/10, you'd get only 1. It would get a lot smaller. Okay, so it has nothing to do with getting bigger or smaller, but what is it? What does it mean to multiply? Well, there's a few different ways to think of it. The first way is that really simple elementary school way that we were talking about in the beginning of this lesson. I said to you, you know, every student in the class has 5 candies. There are 30 students in the class. And you told me that you would multiply. Why, David?
No, it's just easier.
It's just easier than what? Then what?
Adding.
What would be another way to solve that problem or to simplify that expression?
By adding it.
By adding. I could have added the number 5. 5 plus 5 plus 5 plus 5 plus 5 plus 5. Oh my gosh, I have to not have 30 students in the class. My hand hurts. Let's say there were only 6 students in the class. Okay, 6 students with 5 candies each. I could add up the number 5 6 times. That's the long, slow way. Or I could just write, of course, 5 times 6. So one way to think about multiplication is repeated addition. Now that's the easy way. That's the way students are good with. They're like, yeah, Kate, I know that because I always forget my times tables and then I have to add real quick. I'm like, good for you. I'm glad you know it. Okay, but it doesn't do us well for a problem like this. How do you draw 1/3, 1/2 of a time? I'm just saying that this conception of it, repeated addition, would be really hard because I don't have a whole number of times to repeat the addition. I can't write like 1/3, 1/2 of a time. It's just not good conceptually this way. Does that make sense?
Yes.
So I need more of a deeper understanding of what it means to add. That's all I'm saying. We'll talk about multiplying fractions another day. Okie dokie. Okay, so that being said though, what is another way to conceptualize multiplication? Well, another way is putting together same-sized groups. So it reminds me very much of the last one, you know, addition. In addition, we were combining any sized group though, and here we're putting together same-sized groups. If it's multiplying, all the groups need to be the same size in order for multiplication to work. Or thirdly, and this is the one most important to the GED, so, and also the one that students are least likely to know, so highlight it, underline it. Now's the time to pay attention if you've been bored. Scaling. Multiplication is an act of scaling. David, have you ever heard the word scaling before? I bet you have, because you have construction industry, right?
Yes.
I'm actually talking about scaling something's size. Do you know what I mean when I say I'm going to scale its size? Scaling a size is like what we do on blueprints or maps. Scaling a size means, you know, taking the dimensions and either you could pull them out bigger, like when you build a house off of the blueprints, or you can pull in dimensions smaller, like when you make the blueprints based on the house size.
Yeah.
Okay, so scaling is this idea that it can make numbers both bigger and smaller. And so that's a much better understanding of multiplication for us than this more elementary level of just repeated addition or putting together same size groups, because we're going to work with all different kinds of numbers on the GED. We need to understand that multiplication is an act of scaling. So let me show you what I mean. So for example, I could scale 10 up 4 times larger. So if I made 10, like maybe 10 inches 4 times as large, I would get
40.
Or I could scale 10 smaller. I could make 10 half as big. If I made 10 half as big, what would I get? Don't panic about the fraction. Just tell me what you'd get if you had got half of 10.
5.
And why were you panicking? You were going, I don't know how to multiply fractions. Yeah, I didn't have to know anything about multiplying fractions to do that. I just had to understand that multiplication was an act of scaling. I can take a 10 and I can make it half as big. I can make it 10 and I can make it 4 times as big. Now, do you understand then what I mean by an act of scaling?
Yep.
So I'll just write it in mathematical terms. I'm talking about increasing or decreasing the size of a number by a scale factor, by a certain, and it could be, again, a larger factor or a smaller factor. Okay, so those are my definitions for multiplication. So then I ought to be able to take a look. If I can multiply, I ought to be able to do the opposite. I ought to be able to divide. So once again, we have this concept of inverses. The inverse of multiply is divide. It's the opposite. So that means that if I can call multiplication repeated addition, do you know what? One way I can think about division is repeated subtraction. Now that blows a lot of students' minds. What? Repeated subtraction? Well, let me show you what I mean. If I say, I'm going to do a really easy one, and I don't care where you write this. I don't need this in my final notes, but I'm going to just do an example of how 15 divided by 3 can be viewed as repeated subtraction. What am I asking you there? I'm asking you, how many times can you take 3 out of 15? How many times can you take 3 out of 15? How many 3s are in 15? Well, I could just repeatedly subtract. I could take a 3 out, I'd get 12. Then I could take another 3 out, I'd get 9. Then I could take another 3 out of that 9, I'd get 6. I could take another 3 out. Now this is not the way most of us divide because it's kind of the long way. Take another 3 out. And you see now I have nothing left. I used up my 15. Does that make sense?
Yep.
Well, how many 3s did I just take out?
5.
1, 2, 3, 4, 5. 15 divided by 3 is 5 because I had to subtract 3 5 times. It's repeated subtraction. Now that would be the long way to do it. But by the way, if there's anybody in this listening to this video, I don't think David is this type, but if there's anybody who's ever struggled with long division. Long division is the only video I've ever made that's gone viral, I think, because so many people struggle with it. There's another way to do division. Long division is not the only way. I have a way, you should go check out a video called partial quotient division, which is based on this idea that division is just repeated subtraction, okay? So that's one way to envision it. Let's think of another way. We said that one of the definitions of multiplication is putting together same-sized groups, putting together same-sized groups to make a total. So then how could I envision division as the opposite of that? Well, division would be taking that total and breaking it back into those same-sized groups. Okay, and then finally, am I going to relate it to scaling? Increasing or decreasing a number by a factor? I don't think I am. Look at me, breaking my own rules. It's not a real clear connection, and I just don't feel to confuse anybody. So I'm just going to leave that there with division for now. So then I'm going to show you some example problems now.
I think that brings us to the 30-minute mark of the video we wanted to show you guys.
It does. So we wanted to take a minute. That was a lot of information that she had in there. I think the first time I watched it, I was kind of overwhelmed. I actually, the first time I watched that several times. We made a worksheet. I'm going to share my screen here, covering a lot of what she talked about that we think will be helpful for you and your students. And we're going to email this to you, and I'm probably going to start including this with learning plans that go out. But this is the information that she covered, where she talks about addition and subtraction being the inverse, multiplication and division being the inverse. Did anybody feel like they saw things from another perspective or got information that might be useful for their tutors from that? Not their tutors, their students, I apologize. Anyone? It's okay if you're still processing it. It might be a minute before. But this is, just from our experience of talking with students, they really struggle with the concepts of like multiplication and division specifically. And I really liked, it was kind of a whirlwind, but I liked how deep she went into it. One of the other things that we wanted to share with you guys is in the back of our textbooks, we have, I'm not sure if anybody's seen this, in the back of Math Sense 1, there's a fraction chart and a percentage, decimal, and fraction chart that shows conversions. We've been sharing this more with tutors to share with students recently, and we are finding that I think this visualization of this is helping the students kind of wrap their brains around the relationship between decimals, fractions, and percentages, which we know can help students especially help them estimate and help them kind of get closer to an understanding of what these concepts mean, because these are some pretty big concepts. Our plan is to email this to y'all. Do you want us to put this in the chat right now as well?
Isn't this is in the back of Math Sense, right?
This one's in the back of Math Sense. This is not.
Okay. So the first thing would be useful, the Math Sense one. I actually asked one student to memorize.
You asked them to memorize that.
Mhm.
How did that work? Did this help the student seeing this?
I don't know that it did, but it was a student who was impatient with me doing the kind of things that she was talking about, like what exactly is adding and subtracting. And so you have to speed up to slow down sometimes. So I went like, okay, well, start thinking about these and see if you can memorize them, because she wanted to speed up, and part of speeding up is knowing these by heart.
Or at least knowing where to find them, right? Like it's at least knowing how to, if you can't find it today, where can you go look at it? If you know,
Right.
if you're not able to do it today, where can you find this when you need it? And I think that's part of, I think what you're talking about happens a lot with our students, like for good or for bad. They don't understand that they need to understand that these things are inverses until they do, like until they get to algebra and they're like, I don't understand what's happening. So I do think just having like reference is really useful to have, to go back for students and say, let's go back and look at that again. Yes, and sometimes I do think you need to bring them forward for them to understand that it's time for them to move backwards again. I do think that this is going to be useful to give to students as like reference sheets, or to have in a place where you can pull up, so that students can look at this. Because this idea specifically that of things being inverse, I think is really, really important. And I think it's something that a lot of our students are missing. I think a lot of our students kind of dropped out or stopped out of school before that idea really crystallized. So just having a reference sheet, I think, is going to help them. And just me, when I'm talking to a student, I think it helps remind me that I have to cover that concept again, because the students they're not getting it. So I dropped that in the chat for y'all. And also on the bottom of the sheet, I'm not sure if you saw, is a link to the actual website where the video was that we just had. That woman, I find her explanations of most things to be pretty clear. And if you're finding, like we're starting to refer tutors to that website, and when students aren't getting things, to just have them maybe watch the video or watch the video together and then come back and talk about it, because I think sometimes students don't want to hear our voices anymore, and they like when somebody else says it, it makes more sense, even if they're saying the same things.
This is Jacqueline. I'll trust that you know that, but the students that I have, most of whom quit, are very, very easily frustrated. And she frustrated me. She went too fast and it was too much. And I shut down. So I don't know that any student I've ever had that I would send to her. But her concepts, I get.
And that's, I think, what the point of it is that like I could see this being more useful for a tutor to like give them a new way of explaining things. So here's a concept, here's a new way of explaining it. Because what I'm, like you're saying, the students are frustrated, right? They're frustrated, they don't understand. And so having a new way of explaining something can be really useful. Yes, that was a lot of information. And like I said, the first time I watched that, I knew what I was watching made sense, but I had to go back and watch it again because it was just so much information.
Well, and I still don't understand scaling. I see that that's an important point, but I don't have any idea what she meant. So, that's work for me.
But I think that's what this is, right? That's this idea that I had never thought about. In my mind, multiplication was making things bigger, but then I knew that was like an incomplete like I knew I have enough math to know, like, okay, well, you've done pre-calc, you know that multiplying, you know, how do we get percentages? We multiply. But it was the first time I watched that, it took me a couple of times watching it to fully start to wrap my brain around and say, that's really multiplication. It's making things bigger or smaller at the same kind of rate. I'm not sure that scaling is a word. Maybe rate is another way of saying it.
Yeah, I think it's helpful because it's really hard to get to fractions, which is just, you would think we were talking about calculus, but it is hard to say that. And when you get to fractions, multiplying is dividing and dividing is multiplying. So it is, I'm happy to have another try at how to do that.
And that's exactly what we were trying to do, was just to give everybody another resource. And again, I don't expect everybody to retain all of this, but when you are working with a student and you can start to see that frustration, it may be take a pause, go back, find the section where she's talking about it, watch it, by yourself, take a minute and be like, what is my student missing here? Like which piece of the concept are they missing? And just going back and trying to give them another piece, right? Like another piece of that puzzle. And I do, man, Jacqueline, the students get frustrated. They want us to saw their heads open and like dump the math in, right? Close their heads and they can go on their way. And that's not how it works. And we get the same frustration with our English language learners who they just want the language now. And this is a process, takes a long time, and it's a lot of practice. And our adult learners, there's a lot of gaps that we're filling in. So we don't even know that we're hitting gaps until we stumble across them. And I think that's frequently with math. I think people freeze, especially our students. So
yeah, I agree.
This is Kathy. I think that one of the problems that the students I had pre-pandemic, at least some of them, well, first of all of them were former ESL students. So of course they're all from abroad. I don't know what particular symbols have been used in their culture.
Yep.
But one of the things that was definitely a problem was, she said that these are useful for algebra and for word problems. And it was word problems that were what I was teaching at the time. And if the students' English wasn't good enough to read the problem and understand it, then it made it harder for them to know what operation they should be performing.
Yes. And one of the things that we are trying to work on is to try to build in find more resources for word problems. So we have the Math Sense series and the Foundations book. I actually just started working with another math series that I want to bring in specifically for word problems, because I think this series does a really good job of explaining what is the language that you need to know for addition, subtraction, multiplication, and division. What is the language that you need to know for decimals, percentages, fractions when you're doing word problems? Because if you're a native English speaker and you don't have those words, if the GED says, what is the quotient? You're not going to know if you don't know what that means, you don't know what to do with that. Regarding English language learners, yes, I am. If you are working with a non-native English speaker, make no assumptions. I used to work at the university level, and I had a student who got through the entire first semester of an engineering graduate program, very, very, very smart young man from Mozambique. And it was the end of the first semester before he realized that we didn't use decimal points, that he was using commas, and that his professors who were you know, US educated were like, why is this person using commas instead of decimal points in his problems? And he was getting really basic math. He was doing the math right, but he just had like the wrong marks in it. And that was enough for him to kind of crash. And I think that it is worth, if you are working with non-native English speakers, to make sure like the language is there. We also recommend with high school equivalency that math, I know we frequently have students who are kind of working on math and like maybe reading like the language arts section at the same time. The actual recommendation, and Dan, because I know the order that your student is working on things. The actual recommendation is reading language arts first, social studies and or science second or third. Math is actually supposed to be the last one that you work on, because the assumption is that if you're having any issues with language, you will like that you kind of build up your English language that you need to take that math test. And it's usually the science test that's before the math test. Our students don't always go in that order. They kind of go in whatever order. At this point, we just kind of encourage them to go because we're happy that they're with us. But yes, math can involve a lot of reading. And if the students are not strong readers, it's a serious challenge. And I tell everybody that if you're working with GED students, high set students, and they are not strong readers and they're struggling with math, one of the biggest things you can do is get them to read more at home, anything, so that they can start to understand those word problems better. I am just realizing, Miguel, that I am sitting in the dark in this room. The lights were, it was light out when it started and I didn't turn a light on before this started. So I apologize if my background got really blurry. I want to be respectful of everybody's time. We're at 7:58 and we normally run these till 8. We're happy to stick around and answer a few more questions, but I did want to thank everybody for joining us today. This was, like I said, I found this woman about a year ago and I've really kind of grown to appreciate the resources that she has on her website. And I really hope that all of you find, yes, Jacqueline, I agree, she can be frustrating because she talks so quickly. But I do find her explanations for things and just kind of, she really has drawn me to seeing math from another dimension. And I think that that's important for our students.
Yeah. I would also encourage like the tutors just to take a look at her website. She has other resources besides her video. She has worksheets that go along with that, practice sheets that touch on the topics that she just covered in the video. So if you guys want to take a look at that, I also provided you guys the link in the chat.
And we can also, I have all 3 of your names here. We can email you tomorrow with a copy of the sheets that we just showed you, as well as, again, just the link to the website. I do want to thank everybody for your time. Thank you so much today for coming. And thank you for everything that you're doing with our students. We're always just so grateful for all the work that you are all doing. We are
Always happy to have more stuff in the toolkit.
Yes.
Thank you, guys. Thank you very much.
Thank you. All right.